So, good morning. Nice to be here. So, when I submitted this talk, I think it was, 6 months ago, that was pretty much just a plan that we had put on paper. So I was actually kind of nervous because I didn't really know what I would be presenting here when the talk was actually accepted. But that being said, I think the last 6 months have been pretty interesting for us, and I would like to share our experiences at JET with you. So basically the title of this talk is The Saga of Migration. It's JET's ongoing efforts to port existing F# systems to .NET Core. So a few words about myself. I've been doing F# for the past 7 years. Originally, I was just doing maths and theoretical CS, but at some point I moved to development, like many people in my field, I guess. Currently, I'm working on the inventory team at the JET offices in Dublin. And you might have, like the people that have been in the F# conference circuit for a while, you might know me from this list of projects that I put below. I'm not going to enumerate them at the moment, but they are relevant for this talk, and you'll see why later. So to give you an agenda, first of all, I'm going to give an opinionated recount of sort of my experiences with .NET and cross-platform over the years. Why .NET Core makes sense for JET, and detail our ongoing migration efforts, like this is far from a complete initiative. And just to share with you what we faced and what lessons we learned from this initiative. So a few disclaimers before I start. First of all, there will be 0 lines of code in this talk. Secondly, there will be a lot of detailed talk of .NET versions. So if this is, and Visual Studio versions, by the way, and explaining all the detailed and intricate relationships between all of those. So if you really hate this, the fire exit is over there. And finally, of course, you really have to state that nowadays, like there will be opinions here. So to begin with, let's talk about .NET and cross-platform historically. From, I guess, my personal perspective. So before I actually started as an F# developer, I was a hardcore Unix user. The person over there was one of my idols, used operating systems that had puffer fishes as their logos, and tended to hang out with people that were less nice than these two guys. So in 2011, I actually started a career in software development, writing systems in C# and F#. We had to use Windows and Visual Studio. So about that time, the development experience looked like this. Working with F# was very enjoyable. Like I really loved it, but Windows not so much. Some of my friends might have thought that I betrayed sort of, the true way of computing, I guess. But the thing is, I really wanted to keep using F#, so I was, I guess, always kind of exploring the ways of how could I actually keep working on this language, but not necessarily on Windows. But even back then, F# technically was cross-platform, and that was via the Mono project, which is an open source implementation of the .NET runtime. And the editing experience was relatively decent via Mono Develop, currently known as Visual Studio Mac. But the runtime suffered from reliability issues. Just to give you a feel of how major those were, I actually went to Bugzilla in Mono and just searched for the issues that I had filed. And you can see this huge list. Can you actually read those issues? Might be too small, but there's a lot of segmentation fault errors, a lot of base class library bugs, lots of things that basically meant that Mono at the time wasn't really a reliable solution if you wanted to use .NET in production on Linux. So I think the hard reality at the time was that F# was strongly typed to Windows. And that had many ramifications, one of which is that I had many friends at the time in academia, and while they would acknowledge that F# and .NET is a great platform, like they would say this, they hated the fact that you had to use Visual Studio. Like they really wanted, oh, I want to use Linux for .NET, and Mono doesn't cut it. And they just ended up doing most of their cool research on the JVM instead. So I think that really impacted the ecosystem here, because you had so many, like the brightest of the best of CS not working on .NET and working on JVM. I guess the thesis here is that the greatest flaw of F# is that at the time it was not truly cross-platform. One of the themes of this talk is how F# ended up really being cross-platform. So moving on, as you know, there's this thing known as .NET Core. It was first announced in 2015. Like it was promised as the truly open source, truly cross-platform .NET. I was really excited about this. Like finally, proper .NET was open source, cross-platform. And, it came with all the, sort of things like this, cute, I guess. But mistakes were made. Like .NET Core 1.0 still brings some PTSD for me. It was conceived as sort of a re-envisioning of .NET. So like they wrote new build tooling, they deprecated lots of legacy APIs that were no longer relevant to modern development, I suppose. They also like moved most of the class library to NuGet packages, really modular. So you basically had to download the entire runtime all the time. As Aaron put it in his blog, they were attempting to boil the ocean, which I think at the time the criticism was spot on. And you had things like this. Obviously XML is legacy and outdated, and JSON is modern. Therefore, this thing came out. And the code as well, like programming across two different runtimes, two different platforms, wasn't ideal. You would need to have all sorts of compile conditionals, because is-enum obviously had to be consumed in a different way in .NET Core, because that was the more modern way. So I suppose this picture pretty much summarizes my feelings about .NET Core about the time. So the release of .NET Core 1.0, in my opinion, brought important design flaws. Because they were changing so many things out the door, there was limited to no support by the ecosystem. So most of the libraries had to go through the significant effort of porting themselves. F# suffered even more because of that. And as a result of this, I must say that it was largely skipped by myself and many other of my peers. Like, we just decided to stay with, .NET Classic. But we were still hopeful, because we actually knew that, this was a move in the right direction. Mistakes were made, of course, but, eventually, we would get .NET on Linux, we'd get containers, we'd get cool infrastructure, and everything would be just amazing. So I guess this brings us into .NET Core and how we've been dealing with it inside Jet. So a rough summary of the Jet systems, at least until recently, is that most of them are written in F#, at least for the backend. They're targeting a classic version of the .NET framework. Devs were mostly using Visual Studio 2015 because 17 had issues. Our services were hosted on Windows Server, and to support all that, we had a tailored build and scheduling infrastructure. So We were using Jenkins for our CI. We were using Nomad. We are still using Nomad for running our services, but under the hood, like there was a lot of bespoke infrastructure going on just to support sort of the Windows.NET F# combination on Windows Server. Like for example, a constant complaint of our DevOps team was that they had to install Visual Studio in all the Jenkins slaves, and it was a big pain in the ass for them. So maintenance and upgrades were extremely difficult. There were always delays. Like we couldn't really build stuff in a way that's compatible with 2018, I guess. So all this discussion begs the question of, why does .NET Core even make sense for Jet? Like, obviously Jet is just a business that wants to make money. Why should we even care about migration? So there are a few reasons. I'm just gonna. The first one is just a stock argument. It's cool. It's bleeding edge. It's performant. Like everything is so much faster. And of course, it's the future. Like how can you ignore those points? Those are all valid. And in fact, being on the bleeding edge is valuable for a company that prides itself in its tech culture. But there were other issues as well. Like, for one, we could actually finally leverage like all the cool infrastructure that our competitors are using. And more importantly, we would eliminate our strong dependency on Windows Server. Because, let's face it, Windows Server is not really built for our requirements at this time and age. And even more importantly, there are huge cost-saving potentials by moving everything to Linux. Like we did some analysis and we found out that, in Azure, for example, the same Linux VMs are 48% cheaper than the equivalent Windows VMs. So given our scale, that actually translates, eventually, in millions of annual savings in just compute costs. So this cannot really be ignored. So at the time, like amongst engineering and not only engineering, the consensus was that .NET Core is the future. Like we would move to that eventually. It was just a question of when. But until recently, we had no clear migration path. Like everybody was talking about .NET Core, but they had no idea how to use .NET Core. Some brave souls had created a few proof of concept microservices, mostly written in C# because just the tooling experience was much easier back in the day. But at the same time, we were really closely monitoring the progress in the ecosystem in terms of what was happening, how ready F# was at the time. So things really started lining up at about the end of 2017. So about 9 months ago. A few things had happened by then. The most important one, of course, was that .NET 2.0, .NET Core 2.0 had just been released. And for those not familiar with this, the main things that were brought by 2.0 was that it was actually implementing Net Standard 2.0, which basically solved many of the problems that had been brought by the initial .NET Core release, like reinstating deprecated APIs. You could finally run binary formatter on Linux. That sounds like a joke, but it's not really. I think if you have existing software that happens to rely on old APIs, if you don't have those APIs available, it will actually impede your ability to migrate. So it was good to actually have some of those things back. Not everything, of course, but most of them. And the other thing is that, sanity in sort of the NuGet package realm was kind of restored, so you didn't need a NuGet package for system.threading, which was kind of nice. And the other thing, of course, like there were obvious SDK and tooling improvements, like many of the issues in the .NET CLI were improved, the tooling was improved. And of course, we were getting the sense that the ecosystem was gradually catching up. So, like finally, most of the libraries had been migrated. Like most of our dependencies, the Azure SDKs, they were .NET Core ready. More importantly, MS Build is back. I mean, in itself, it's no reason for celebration, but it actually made the migration path more straightforward. And in a way, it was nice. Sure, it was like old and outdated XML that our fathers would write. But you could actually fit a project definition in just a few lines of XML, which was definitely welcome. If I were to show you the equivalent XML required for the legacy projects, I would have needed 17 slides. And from our point of view, the most important thing that happened at the time was the release of Visual Studio 2017 Update 5, which, by the way, is version Visual Studio 15. So Visual Studio 2017 is Visual Studio version 15, which is different than Visual Studio 2015, which is Visual Studio 14. Just so you know. But the important thing with Update 5 was that it finally brought support for .NET Core projects, which was absolutely amazing for us, because we are Visual Studio users, more or less. So all those things were pointing towards the fact that the platform was reaching a degree of maturity where we could actually be serious about it. So we started some initial trials, led by myself. One of the things that I first tried, because I'd literally never touched .NET Core before, was attempting to port one of my own libraries. So I started with Argue. Most of you have used this because if you use Packet, you are referencing this library. It's being used for the CLI. And the reason why I chose this to port to .NET Standard 2.0 was it was a very good pilot experiment. It's a very small library. I'm not sure how many lines of code, but it's definitely below the 2,000 mark. Has absolutely no dependencies, and relatively popular. Like Stefan was constantly complaining about it not being migrated to the most recent version. So I set off, but there were problems, of course. The main one, of course, was the learning curve. Like I needed to sit down and work out the .NET CLI. I had to work out all the differences in tooling, blah blah blah. Of course, Visual Studio performance issues. Like if anybody has used Visual Studio before Update 7, using F#, you would have certainly come across this. The other issue was that it had no support for multi-targeting. Multi-targeting, for those of you that care, is basically the ability to reference two different target platforms in a given project. So the lack of support of that for Visual Studio meant that I actually had to duplicate the project, one for .NET Classic and one for .NET Standard. There were some packet issues, so like I came across quite a few bugs that as with everything new, like it didn't work well with the latest Visual Studio tooling. NuGet packaging for multi-targeting also didn't work well. So there was a lot of improvisation, actually, and manual work. So I actually had to manually create my own NuGet artifacts, by manually zipping and all sorts of things. But ultimately, the experiment was successful. So around that time, I had ported, that small library. It was, despite the problems, the experience was relatively smooth, far from perfect. But it kind of signaled that we can actually take a deeper look here. So by the first couple of months of 2018, we had quite a lot of progress, so fixed many of the packet bugs, and I would like to thank Stefan and Enrico for helping a lot there. Like I did most of the reporting, they did most of the fixing. And at that time also, Visual Studio Update 6 had been released. It added support for multi-targeted assemblies, feature completeness. You could finally, reorder files within your project. Amazing. And it also came with modest performance improvements. And at the same time, I was able to also migrate like the remainder of my own library, so I was increasingly gaining confidence that the tooling was actually very close to being used for production. So conditions had matured for a jet migration plan. So around that date, we started internally the .NET Core initiative, which was basically like a group of engineers that were sort of investigating migration plans for production systems within Jet. It was a cross-team undertaking, and it involved both developer teams and some of our platform engineering. Just list some key contributors other than myself. You might know Enrico, for example. All of them really helped making this possible. So I would like to detail some of the key goals for this initiative. The first one was that we didn't want to only target greenfield projects. Like we really wanted to migrate existing systems and do it in a way where we actually have no disruptions in either stability, reliability, or our ability to deliver new features. And that would involve basically a phased migration of production systems. So we wouldn't make a big bang conversion from, .NET Classic one day, .NET Core on containers the other day. No way. At the same time, we aim to minimize churn on dev teams. So all that crap about .NET versioning, Visual Studio versioning. I just didn't want to expose the dev teams to all the minutiae of that stuff. It should just happen. They should check out the code and continue working on features. Contain production risk, as I said. So moving on, I would like to say some of the challenges that we identified before starting the actual initiative. The first one is that we actually had to move the dev teams to the new tooling. And in our case, that meant updating to Visual Studio 2017. As I mentioned, there were serious issues, so we really wanted to avoid exposing our developers to Visual Studio 17 before the main reliability issues were addressed. The other issue was that our built-in infrastructure just didn't support the .NET Sdk. We had to upgrade it, and that was a difficult ask to us from our DevOps team. The other thing, of course, is that when you have a 4-year-old code base, chances are that you might have picked up dependencies on all sorts of deprecated APIs, Windows native stuff, who knows. Libraries that haven't yet been ported to .NET Standard, of course, those always existed. There also exists the possibility of you depending on a library that will never get ported to .NET Standard, and we had quite a few cases of that as well. And, of course, libraries with Windows native dependencies. All those things would have to be somehow worked around with or replaced or whatever. So regarding Visual Studio 2017 stability, we worked very closely with the Visual F# team reporting issues, and actually Jorge, who is here, really helped sort of keep in touch with Philip and sort of constantly reporting any problems that we were politely put complaining about. So over time, performance and stability fixes had accumulated. Like I mentioned before, multi-targeted projects, a critical feature for us was added. General feature parity with legacy F# projects, the initial release wasn't quite there yet. Now it's more working with an old F# project. And would like to thank Philip for that. Is he here? Probably not. But Philip Carter, the F# PM, he was really engaged in this conversation, and he actually came. He went to the Hoboken office and he came to the Dublin office as well, where he basically faced an open table of really angry engineers, and he basically took notes of everything. And soon enough, we had Visual Studio 2017 version 15.7. Remember version 15, 17. Not Visual Studio 15, anyway. So Visual Studio 15.7 was released, and I have a screenshot from a tweet I posted at the time, where basically I actually had an F# solution running on Visual Studio. I had compiled a couple of times, run a few tests a couple of times, and it was actually the first time that the memory footprint was under 1 gigabyte. Way below 1 gigabyte, actually. So that was really impressive. A very dramatic improvement in performance. And at that point, we actually started recommending dev teams to upgrade to Visual Studio 17. We thought that we had finally reached that point where Visual Studio had the stability required for us to keep on working, basically. As far as infrastructure upgrades were concerned, one of the first things that we did is we decided to skip Jenkins altogether and we moved to VSTS. So we just migrated our CI jobs to VSTS, and we leveraged the already existing .NET Sdk and Docker builds. Another major effort was internally at Jet, we have dozens of shared libraries that all teams are referencing, also known as Marvel. There was a big effort to actually migrate those to .NET Standard. And I should say that Enrico also helped a lot in that, Enrico Sada, in that effort. And this effort, of course, also included open source libraries like Kafunk and async-seek. So we were actually able to port those. The other thing that we did was we decided to upgrade our Windows server infrastructure to Windows Server build 1709 in our Nomad systems. Basically, that brought many benefits to our infrastructure, but more importantly, from the migration point of view, it added support for .NET 4.7.1. I will explain just now why this was significant in our initial migration plans. So without further ado, I will sort of list the steps that we decided to take, at least on paper, for migrating our code bases. So as mentioned, this was like a phased migration, so we would gradually make changes in the code base while ensuring within every step we were still able to continue deploying to production, to continue to make feature changes, etc., without any disruption. So the first step was, of course, to migrate all projects to .NET Sdk. The cool thing about .NET Sdk is that you can actually use it to target classic .NET platforms. So you can actually make the change on your build SDK without actually changing anything about the bits that you're actually deploying. That was a pretty major thing that you would need to do, but it wouldn't really impact the services that you are deploying. The second step after that is done would be to upgrade the running services to .NET 4.7.1. Now, .NET 4.7.1 is a branch of .NET Classic. However, it is actually one of the first releases of .NET to be capable of consuming .NET Standard libraries in a way that doesn't introduce problems. So basically, that meant that for step 3, when that was done, we could actually work our way backwards and gradually migrate all the dependencies for the services to .NET Standard. So we could actually keep deploying .NET 4.7.1 while slowly removing obsolete dependencies, making everything .NET Standard ready. When that was done, and all the dependencies were .NET Standard, it was simple. We just switched services over to .NET Core. So we actually changed the runtime of the service, still running on Windows, though. So you have now .NET Core running on Windows, and as a final step, when you're actually confident to make the move to containers, switch services over to Linux and Docker, which should obviously be the easiest step, right? So the current status on the cross-team, from a cross-team perspective, is that as far as I know, at least 6 Jet teams are running .NET Core in production. It's partially migrated, not everybody is running everything on .NET Core, and not everybody is running a .NET Core on containers, so it's basically an ongoing process. It is also a mixture of greenfield and old systems. I think most of the greenfield systems nowadays are directly written in targeted .NET Core, while the migration of the old systems is an ongoing process. And we have a long way to go. There are many systems, there are millions of lines of F# code that we still need to work through. So to give you a case study, I present to you unified inventory. If anybody attended Scott Haven's talk from yesterday, this is basically sort of the DevOps perspective of the same system. The reason why I chose unified inventory, because I happen to work on the same system. Basically, unified inventory, the name suggests it's just the inventory management system for both Jet and Walmart. It was forked from the Jet inventory system. And nowadays, it amounts to about 60 microservices and 90,000 lines of F# code. So this is, I would say it's a pretty big F# project. Some of the architectural keywords, it's event-sourced, relying on Kafka and Cosmos DB primarily. So what is the current status of unified inventory? We're fully migrated to .NET Core 2.1. Everything is running .NET Core as we speak. But we're using hybrid Windows and Docker deployments. The great majority of services, though, are still deployed on Windows Server. Why is that? It turns out that networking performance is still a major issue on Linux as far as .NET Core is concerned. We have many clients that have not been optimized for the Windows networking stack. And a few examples are HTTP client. There were known issues, serious performance issues with HTTP client that were at least partially addressed with the release of .NET Core 2.1. But the ongoing issues that we're having at the moment is with the Cosmos DB client, where actual load tests that we made indicated that basically moving the exact same client to Linux produced a doubling of P50 latency. So in terms of the original plan of migration, we're actually still in step 4. Step 5 is something that we haven't yet achieved, like we're not running 100% on Docker, but it's something that we're working on. And I suppose that we'll get there. So, lessons learned. Some of the good stuff. The migration to .NET Sdk was straightforward, relatively. There is, of course, a learning curve. There is a lot of manual work to do because we have no automated migration tools. But overall, once the migration was over, we received mostly positive feedback for developers. Like they loved the fact that the new SDK is much leaner than the old one. Another thing was that converting libraries to Net Standard 2.0 was relatively easy, at least for us, and I should say this. We had very few deprecated APIs, and I think that's also a testament to .NET Standard 2.0 tackling most of the issues that .NET Standard 1.0 had brought. And also most of the dependencies that we were consuming had already been ported over, so we had not many issues. Anything that happened to be unsupported, like we easily replaced with either drop-in replacements or we just completely worked around those. Other good things. VSTS, also known as Azure DevOps nowadays, is really a breath of fresh air. Like, really enjoyed making the switch from Jenkins to a VSTS. Sorry, Azure DevOps. One of the things is that we really enjoyed the pipelines and the Docker builds. Everything is very easy to edit. Also really like the test reports. It's a very good tool, and I definitely recommend it to you. The other thing is that we're actually gradually starting to adopt JetBrains Writer. And I must say that we're mostly happy. There are some issues, of course. But I do think that I will be changing my laptop to a Mac very soon. How about some bad things? The main thing, of course, is almost complete lack of any migration tools. Like, if you want to migrate an F# code base, you're pretty much on your own. There's a lot of manual XML splicing. Personally, I used and abused a lot of regex to port over 60 microservices. There's a lot of experimentation, there's a lot of improvisation, but like, it is possible, but it's just going to be a pain to get there. I must say also that I've been pretty frustrated using .NET Test. I find .NET Test to be a very good tool for small projects, and it's very well attuned for demos. But in the context of doing CI in a very large project, I did discover that there are quite a few limits, and I really had to jump through hoops to achieve functionality that you could very easily get with the legacy tooling. So I do think that there's a lot of improvement to happen there. The other thing is that, remember that step about migration to .NET 4.7.1? In our case, it actually never happened. Because turns out .NET 4.7.1 did have serious tooling issues. Like, this advertised ability to consume a mixture of classic .NET and .NET standard libraries didn't really play out in reality. There were all sorts of strange build time warnings, issues, errors. So in the end, it was actually easy enough for us to just make, a sudden switch from .NET standard, from .NET 4.6.1 to Netcore app directly. And I think the most important issue that underlines sort of the outcome of this migration is that we underestimated the Linux migration factor. Like even though your project might be fully running in .NET Core, that doesn't by any means imply that it's ready for Linux. The operating system is a very important factor, and it should never be underestimated, I guess. But I do suppose that this is just like the initial problems, and any sort of divergences in either performance or correctness across the operating systems will be eventually sorted out. So I'm optimistic about that. How about some ugly things? The first thing is that, dev tooling isn't truly cross-platform yet. Like, we're getting close, but, ILSpy doesn't work on Mac yet. I've heard that they're planning to do that, but I really have to use Windows, at least for the next year, I think. And by extension, that actually means that there is a discrepancy between the developer environment and the deployment environment. Like if you're developing on Windows and testing some code that works fine on your laptop, it doesn't really mean that it would behave in the same way when you deploy on Linux. Of course, this is solved by testing in the deployment runtime, but it still is a source of confusion that should definitely slow down things. The other thing that I want to say is, how is solution files still a thing? I mean, moving to .NET Core makes this really evident. Like, I have zero use for solution files. And to be honest, in our build script, I actually have some code that generates the solution files, either to build or to run tests or to do any sort of combination. Like, it's practically, I think, the only way to sort of do things in a grouped way in multiple projects. Just get rid of it. We don't need it. And finally, I really miss F# Interactive. It is currently impossible to consume .NET Standard projects from F# Interactive. I must say that this has fundamentally changed the way that I develop code. I've kind of lost the ability to do sort of old FSI-style rapid prototyping. I'm more like a C# developer nowadays, mostly TDD, lots of console applications. Like, please bring back F# Interactive for .NET Core. So, I guess just to give you a summary of all the points so far, I should say that .NET Core is here to stay, and clearly not another Silverlight. It is really the future of the platform. If you're on .NET, you're effectively legacy, and you should definitely consider migration at some point. There is actually a viable migration path for F# projects nowadays. It's not easy. I'm just saying that it's viable. It is a non-trivial exercise, and there are no clear guidelines. It's just a discovery process at the moment. And of course, or of course, you can hire Enrico. Enrico is a wizard. Like, he can migrate your project in like 5 minutes. There's a lot of manual work and improvisation required. The other point is that maturity of the ecosystem has improved dramatically. Like, compared to the .NET Core 1.0 days, forget about it. Like, it's much better. But there are still crucial components missing. And as mentioned before, dev tooling is not truly cross-platform. And another disclaimer, your mileage may vary. Of course, not all projects are made in the same way, so it might be less difficult or more difficult or impossible if you try to make the same migrations. So take all this information with a grain of salt, I suppose. So, for a conclusion, I must say that F# over .NET Core has evolved into an actually mature platform. We are witnessing continual improvement, like month by month, things are improving in a very dramatic way. So we can only be optimistic about this. F# is finally a truly cross-platform language, and that means that it has also finally become a first-class citizen for the cloud. And 2018 is really a time to be optimistic about F# and its future. And I can replay this animation, F#, .NET, Linux, Docker, whatever that is, unicorns. And Richard Stallman approves. Thank you. And one more thing, I must say also, a message from our sponsors. We are hiring. So if you're looking for F# roles, we have open positions in the Dublin office, Hoboken office, and actually Sunnyvale here in California. So if you're interested, come talk to me or go to the Jet booth. That's it. Any questions?
Yes, I was wondering about the networking performance issues. Were they like the HTTP server, or were they?
It was on the client side, actually. I do know that the .NET Core 2.1 release did many things to address that issue, and at the moment we're seeing that it's not as fast as Windows yet, but it's very close. So the question is if we're using Fake for our build jobs. The answer is yes, we're using it. Of course, in the context of Docker builds, it means that, ironically, we need to use Mono for that. We're still in Fake 4, by the way. I should say, though, that I do believe that the relevance of Fake in the context of the .NET Sdk is not as significant as it used to be. I do feel that just a basic bash script should be just as effective. How many?
How many teams Jet have? I just want to see the percentage.
How many teams does Jet have?
30? Okay, so 6 teams have migrated.
Not fully migrated, I should say. They are supporting systems in .NET Core.
And there are teams that are currently trying proof of concepts without taking smaller parts of the application or in that direction. But not in production. When you also 6 teams are in production.
We're still mostly Windows, yeah. Anything else?
Can you go more into your problems with running a net standard 2 independent framework? There's a lot of real out there, and I'm trying to understand, is it okay to ship only net standard 2 versions on our libraries?
That is a very good question. Definitely, if you decide to say, I'm not going to support .NET Classic anymore and just go to .NET Standard, the migration should be easier for you, actually, because you don't have to go through the pain of multi-targeting. But I do think that at this point in time, it might be a bit premature. So the strategy that I do for libraries is I multi-target, and I target a very conservative version of .NET Classic, usually Net 4.5.2 or something like that, and Net Standard 2.0 for the Net Standard stuff. Very few, surprisingly. They've fixed many things. The APIs are essentially identical. There's some things missing, so if you're using app domains, that won't exist anymore. I believe service model is gone, but 80% of the stuff is back. So it's pretty solid. Yeah, always testing both, I should say.
Just a real quick sec. You mentioned the font was migrated over. Is that still in production?
That's a good question. Since then, we have actually started moving away from Kafunk and into ConfluentKafka.net, just because it's officially supported. Anything else? I use VS Code, just not for F#. So I would need to look up the actual issues because it's been a while and I don't remember. But I do think that it was effectively performance issues because of the differences between the Linux and Windows networking stack is all. I believe, like, we did find this out internally in our own testing, but I'm pretty sure, I think the ASP.NET team also blogged about that. And I believe HTTP Client Factory was, in a way, an attempt to mitigate that, though I'm not exactly sure about the details. Okay.
Don't forget to talk back.
Thanks.